lesson 2, significant digits or significant figures, often called sig figs for short, or sig digs for short. I usually say sig figs. Really, Alec, how to round off in science. What's the difference between $600 and $599.87, besides the obvious 13 cents? What's the difference between those two numbers? One is more precise than the other. Scientifically, we say that one has more significant or relevant digits than the other. Now, there are English rules for figuring out how many sig figs a number has, and I'm going to give them to you, but it's much easier for me to do a bunch of examples first so you can just see what it is, because explaining in English is, So, 600, we would say, has 1 sig fig. 599.87 has 5. Pencils down, look up. Give me a second. Pause the video. Put your pencils down, look up. Okay. How many sig figs? 1. How many sig figs? 1. You make that a little darker. How many sig figs? 1. 2. 3. 3. And it's that one that I just did, which explains sort of why the one above has to have 3. It just happens to be a 0 in the middle there, but it's significant. It's part of what we measured. Two. Okay. Now for the weird ones. You ready? Two. Because, you know what? Why would I have written that last 0 unless that was actually the value that I happened to measure? The same way as the previous one, that 1 was the last value that I happened to measure. This one just happened to be a 0. It's a significant measured figure. That's if I want to show, look, whatever I was measuring here, Gracie, I was clearly rounding off to the nearest 100. What if you were actually rounding off to there and you just happened to get exactly 500, not 499, not 501? How do I show that to somebody? I put a decimal there saying, that's where I stopped measuring. These digits are significant and measured. They just happened to be zeros. Now we're going to practice this a whole bunch, but let's actually do this in the rules. Do you see why? It's easier for me to do a bunch of examples, and then what are the rules? Any non-zero number counts. So 456, 3. 0.9723 has 4 sig figs. Zeros to the left is that way, of a decimal point count. The second one, 690, has 2 sig figs. We're assuming that whoever measured this was rounding off to there, and that 0, they just stuck that on as a placeholder. 3 sig figs because of that decimal point. Brisa, we're assuming this person was measuring to the nearest 1. It just happened to be 0. Okay. Zeros to the right of a decimal point are tricky. If there are non-zero numbers to the left of a 0, they count. Otherwise, ignore them. We're going to come back to the first one in a second. The second one. We're assuming every one of those was measured. So zeros in between, we count them if they're in between non-zero digits. The third one. How many sig figs? 2. The fourth one. How many sig figs? 3. The last one. How many sig figs? 4, because why would I have added those extra zeros on unless they were measured values? And now let's go back to the very first one. How many sig figs? 4, because why would I have added those 2 extra zeros after the decimal point unless I happened to have measured those? This is really the science rules for comparing measurements. Really what we're saying is, hey, what if you're using a meter stick that's accurate to the nearest millimeter, and you're also measuring something with a caliper that's accurate to the nearest micrometer? How the heck do you compare those measurements? What are the rules? So the first thing we have to be able to do is figure out how many sig figs there are in a number. You got it okay? And you're going to practice this. Then we have to do math with them. There are 2 rules. There's one rule for multiplying and dividing. It's the easier one. There's one rule for adding and subtracting. It sucks, but it's the rule. Okay? So multiplying and dividing with sig figs, what you used to call rounding off, now we're going to call it sig figs. That times that. The first thing you're going to do is type it as is on your calculator. So get your calculator out. .74 times 2.0002. I'll give you a hint. I'm probably not going to write that. Okay? But here in part A, because I think I have part A again later on. Don't I, Mr. Dweck? Yeah. Oh, not yet. Okay. I have the answers. Where do you round off? Here's what you do. And until you get good, you can write this down. Eventually, you'll be at the point where you'll just do this in your head. 6.74, how many sig figs is that? Write down a little tiny 3 right there. 2.0002, how many sig figs is that? Write down a little 5 right there. What 2 numbers, Tato, have we just written down? What's the smallest number that we wrote down? We're going to go to 3 sig figs. We're going to round off to 3 sig figs. So here's what that means. On my calculator, the 1 is the first sig fig. The 3 is the second sig fig. Right there, the 4 is the third sig fig, but I need to decide, does it stay a 4 or does it become a 5? What's next to the 4? So will the 4 stay a 4 or become a 5? 13.5. This is what I was doing in the answer key that we went over earlier in class, if you're wondering how I knew what to round off to. B, again, before you do any rounding off, you type in the whole question as is. Get that? Sasha, how many sig figs is the 6.4? How many sig figs is the 9.088? Sorry? Yes. What's the smallest number that I wrote? By the way, you see eventually you can do this in your head and just track it, but for now in our notes, what's the smallest number of sig figs? 2. What am I going to round off to? 2 sig figs. So now I go to my calculator. 2 sig figs is right there. I look to the right, right? The 7 is the first sig fig. The 0 is the second sig fig. Is the 0 going to stay as 0, or is it going to become a 1? What's next to the 0? So does it stay or round up? And now you're starting to see why it can be that you have to have a 0 after something just hanging there. That's because that was rounded off correctly to 2 sig figs, and that is 2 sig figs. Okay? So I wrote down here, rule 1, don't round off until all your calculations are finished. Rule 2, round off to the smallest number of sig figs represented. So see example 1, example 2, example 3, and example 4. They're all variations of the same question. Why don't you try them on your own? I'm going to freeze the screen. Let's see if we can all get the same answer. Do them real quick. I'll do them here. When you're done, you can look up. I got those. Yeah? Example 3 and 4 are interesting because in both of them you're multiplying by 5, but in the first one you're multiplying by 5.0, so you're going to go to 2 sig figs, which is 68. The second one, you're multiplying by 5. You're going to go to 1 sig fig, which is 7, but I have to put a 0 there to show you that it's actually 70. What if I wanted that 70 to look 2 sig figs? I would have done that, but I didn't do that. That's 1 sig fig. Is that okay, Sarah, right? Yeah. I looked at the 6. Okay. Going to become a 7. Oh, but I can't just write the 7. It's 70. That 0 was just a placeholder. Okay. So multiplying and dividing is easier, sadly. You count the number of sig figs and you go to the fewest number of sig figs when you're done. Adding and subtracting. Some of you might get good enough to do the adding and subtracting rule for sig figs in your head, but until you get good enough, unfortunately, it usually requires rewriting the question vertically so the decimal points are in line. I did it for you for this one. What if I was adding 4.567 plus 9.0? I would rewrite it vertically so my decimals are in line. Want you to notice, I know both digits in this column. Yes? I know both digits in this column. Yes? But here is where I have a gap. Right there. Keep that in mind. As before, you don't round off. You start out typing into your calculator exactly what they gave you. 4.567 plus 9.0, not that the 0.0 changes anything, but okay. And I get this, 13.7. I'm going to write 13.567. That's not my final answer. It looks like the last column where I know everything is this one here. This one here. I'm going to round off to that decimal place. In other words, I'm going to look at this 5 and I'm going to say, does it stay a 5 or become a 6? Okay, so the final answer is going to be 13.7. 6. Now I want you to notice something, Zach. How many sig figs does this first number have? How many sig figs does this number have? How many sig figs does my final answer have? In other words, it's not like before where you're counting sig figs. In fact, my final answer has a different number of sig figs than any of my original data. But that's how it works. And the argument is, because you don't know this number right here, all of these are really just a guess anyways. You don't know what was sitting over there. So rule 1, use all the known digits in the calculation. Rule 2, round off to the last decimal place that both numbers have in common. I find it easier to do an example than try and figure that out from English. Let's do a couple more. Oh, no, I'm not going to do a couple more. We are going to do a couple more. You ready? Let's add 5.638 plus 14.9276. 5.638 plus 14.9276. I would write it vertically. I would go, okay, 5.638 plus 14.9276. Can you see where I'm going to stop? There. Now pause. Look at how I wrote it sideways. Could you see that looking at each number, you can actually, if you're clever, figure out which column it's going to round to without rewriting it? And if you get that good, Brisa, go ahead. I'll be honest, I don't need to rewrite them vertically anymore. I can imagine them vertically and just figure out where I'm going to round to. Okay. 5.638 plus 14.9276. There's the answer, but I'm going to round to the third decimal place. The third decimal place. I'm going to look at that 5. Is that 5 going to stay a 5 or become a 6? Get around. So 20.566. Which has 5 sig figs, which never appeared anywhere in the original question. But that's the adding, subtracting rule. Okay. We need to practice this. Video, world's roundest object, I already showed you that one. I'm going to show you something else in just a second. But so for your homework, first of all, how many sig figs in each number? What's really nice about scientific notation makes it really easy to tell how many sig figs there are. For example, number 4, 4 sig figs. Number 9, 3 sig figs. Because scientific notation is really easy to count. Okay, I'll let you try the other ones. And then solve the problems and round accordingly. There's some multiplication questions. And then there's some addition questions. I'm going to give you some time to work on this, and then in about 10 or 15 minutes, I'm going to call you back, okay? And also you have the other scientific notation sheet, the radioactive cat one.